Hello, welcome to my today's presentation under the question that was tested in IGCSE from force and motion. So without further ado, I'll just go straight to the point, to the question, and try working. And basically we'll use the knowledge from force and motion to work out the question. So the question reads, a bus travels along a straight line. The graph shows how the velocity of the bus changes during a journey. So if we have a look at this graph, this is a velocity and time graph. So we are told that a bus travels in a straight line. So if you have a look at this graph, we note that the bus started at point 0. And it traveled at a velocity of 12 meters per second, and then it stopped here at the velocity of 12 meters per second. And at this point, we say that this is constant velocity. And then from point 0 to 12 meters per second, this is acceleration. It's a positive velocity. And then going forward from point 12, from 12 meters per second, going back down to 30 seconds, to 0 meters per second, we call this deceleration because the bus was going backward. So this is a negative acceleration, which is also known as deceleration. So the bus again took a rest at 30 seconds for 10 seconds, and then it started the journey again from 40 seconds, and then it went to 11 meters per second in 45 seconds after 5 seconds. So again it took a rest from this point. This point is 45 seconds. Then it started traveling again to this point. This is a constant velocity. And then it started its journey again downwards, which we said it is decelerating back. It is decelerating at, and this is deceleration, so it means we get a negative acceleration, which is also called deceleration or retardation. So let's go to the question. State the velocity of the bus after 25 seconds. So when you are given this question asked about the velocity from the graph, we should be careful on how we should answer this question. I know some of you may just go to the graph and take the point that coincides with 25, but that is not the way we are going to do this question. So what we do, we go to 25 seconds. I'm sorry, this is supposed to be seconds. So this is 25 seconds at the middle here. So what I'll do, I'll just draw a perpendicular line here. So let me say this is my 25 here. Yeah, what have we formed? This is a small triangle. And then I'll take a point at, if we have a look at this is a small triangle here. Yeah. I can also drop another point here from this region. Yeah. So we have so many methods that we can use to work this. We have so many methods that we can use to work this. So I'll use the idea of similarity, because if you have a look at this, this is one triangle we have here, then we have another triangle, the small one here. So I'll use the idea of similarity to find the velocity at this point, x. This is the point that we are given. Don't take the value that you are given there. Just work out so that you can be able to find the value. So this is what we'll do. We'll say, let me just draw the big triangle. So this is my big triangle. My big triangle from this point to this point, it is 30 minus 20, which is 10. So it is 10 seconds. What about the height? 20 from 0 to this point is 12. So this is 12. Yeah. Then take this small triangle. From that to the middle here, this is 5. And then now, what you are asked to find is the velocity from down here to this point. We don't know this. Let's say this is x. This is x. So what do we do about similarity and enlargement? Similarity and enlargement, the base and the small base, they are the same. Then the height, the big height are the same. That is similarity and enlargement. So it will be 10 from the large triangle, from the big triangle, divide by 5 from the small triangle, is equal to 12, because we started with the big triangle. 12 divided by x from the small triangle. So how do we find it now? We cross multiply, so that we can find the value of that answer. So it will be 5 times 12 is equal to 10 times x. 10 times x. So let's work out this. What is 5 times 20? Or what is 12 times 5? So 2 times 5 is 10. 0 you can 1. So 1 times 5 is 5, plus 1, 6. So it is 60. So we say 60 is equals to 10x. So we need to find this value of x. So we divide by 10. Divide by 10. Cancel 10, 10. Then 0 cancels with 0. So x will be 6. X will be 6. So the velocity here is equal to 6 meters per second. 6 meters per second. So we go to the second question. How long is the bus stationary during the journey? How long is the bus stationary during the journey? So stationary means how long did the bus take a rest? We go where there is a constant velocity. The bus was not moving. Yeah. So this is it. The bus started from this point and it stopped here. For how long do you see? If we consider this and this one, this is at point 20 and this is at point 10. So it is 20 minus 10. That is 20 minus 10 is 10 seconds. So the reason why I took this 10 is because if you have a look at this, it means the bus is at rest. It is not moving. So it is at constant. The velocity acceleration here is 0. So again, it started moving here Then it came to rest here, down here. It took a rest for how long? This is 0.40, and then this is 30. So we subtract 40 minus 10, 30. We get what? 10, so plus 10. So again, after moving, the bus took a rest here. So basically, I'm sorry for this graph, we can't, it's not correct to the point, but let me just allow me to use the graph that I drew as an example. So the bus took a rest at 45 seconds. Then again, if I consider this is 55. Let me just draw a perpendicular line here. This is 45 and this is 55. So 55, this is a point of rest again. So it's 55 minus 45, we get 10. So what if we had this? So it is 10 plus 10 plus 10 is equals to what? 30. So it took a rest for 30 seconds. Are we understanding this? Thank you. Let's move on. So the next question we are asked, state the equation linking acceleration, change in velocity, and time taken. So basically, this is where we go back to the definition of the terms. What is acceleration and what is velocity? We need to understand this. So talking about acceleration is the change. So we say acceleration is the change in velocity per unit time. So acceleration is the change in velocity per unit time. So again, we can write this in initial. Acceleration, so from the definition, we can say that acceleration is equal to change in velocity divided by or per unit time. So change in velocity means what? So we can say acceleration can be also written as A. Time can also be written as T. So basically we can say that acceleration is equals to V minus U divided by T. So A stands for acceleration. A stands for acceleration. V stands for final velocity. And then U, let me write here. U stands for initial U stands for initial velocity. Then T, it stands for time. Together? Yeah, so that is where we come up with the equation that relates with acceleration, change in velocity, and time taken, which is acceleration is equals to change in velocity per unit time. So we go to the last question. The last question reads, calculate the acceleration of the bus during the first 10 seconds. So we go back to the graph that we are given. We are asked to find the acceleration during the first 10 seconds. This is the first 10 seconds. If you have a look at this bus, as it started moving, it stopped at this point. This is acceleration. At this point, this is acceleration. This is constant acceleration, and this is deceleration. So basically, we take a perpendicular line here. So as we said acceleration is equal to final velocity minus initial velocity, which is u, divided by t. Therefore, acceleration will be, but before we work out acceleration from the graph, what is the initial velocity here? The starting point, right? So initial velocity u is equal to 0 meters per second. And then final velocity, go back. Final is where it stopped. The maximum velocity here is 12 meters per second. So it is 12 meters per second. What about time? We already told in 10 seconds. Look at this. This is 10 seconds. So it's equals to 10 seconds. So let's work out now. Let's work out the equation. So it is v, which is 12, minus u, which is final velocity 0, divided by 10. So acceleration here will be 12 minus 0 is 12, divided by 10. Then, therefore, acceleration will be 10 divided by 12 divided by 10, 1.2. Acceleration, what is the SI unit for acceleration? The SI unit for acceleration is meters per second squared. And this is our answer for that. So unless there is another question, this will mark the end of the question. Unless we have a question for this. Thank you so much for the attention. This is the answer to the question.